28. I think I'm figuring those out, but I'm just so uncertain about whether or not I'm doing it correctly.
All right, guys. So.
Oh, I was like wondering. Right on three. Every day. Can you hear me? I definitely know this.
Just you, sir. Of course. So that was the appropriate response to what I just wrote up on the board. Oh, just you sub. Yes, just you sub. So we want to make sure that everybody can do you sub.
Only that one topic, right?
Just you sub. No shells or washers or discs or mine.
Will it be infinite and the interval on it too?
Indefinite?
Oh yeah, sure. Indefinite and definite. So you can pick whichever way you want to do it. The way I did with my parentheses, or you can actually change the limits when you have you defined. Cool. Either way. So make sure you know how to do that before Monday. Because I want to do that so I can give it to you on Tuesday, because I'm giving you Wednesday off. So I want to make sure you guys have the quiz returned to look at over the Thanksgiving break, or to stack in the corner and not look at until later. So, remind me which one? It was 6. All right, so we're looking at 6-2, number 6. Shut up. Big quiet.
You won't be able to resist offering that. About 3 quarters of a bag.
Good Lord. About the y-axis. So right there, it's about the y-axis. So if we want to use, we have to, because it's the only one we know, we have to use the disk method, which the washer method, when I say disk method, it could mean that, because they're the same. Is everybody cool with that?
Yes.
All right, I like it. So we have to use the disk method, because that's the only thing we know. So I want interval will be what? Because it's parallel to the y-axis. The y-axis is. So which means I need functions of y. So this will be x equals either y. I like it. And this is telling me what y is doing. So let's try to graph this region. What's x equals 0?
Y. That's my axis.
Y-axis. I like it. So my region is bounded by all those things. So let's see. It's bounded by y equals 1 and y equals 2. That's nice. And let's see, what else do I have? Let's put some stuff in here. Alright. So y equals ln of x. Or x equal to either y. So when y is 1, x is what? X is e. So I'm at e. So let's make this 2, 4, 6. And when y is 2, x is e squared, which is about
2.75 squared is like 4 or 5.3.
it's almost 3, so it's more like 8 or something. Nobody has a calculator in a math class? This is horrible.
Hey, you're the one who keeps telling us not to use calculators.
Well, I just said 2.
And he returned to the back end. Alright, 7.389. So 7.39. Okay.
So then 2.7, so 2.7, that's at 1. And at y equals 2, it's at 7.4. So right there. Bam. I like it. And in terms of the way we're used to looking at it, it's this function, right? Y equals ln x. So ln x looks like that, so it'll be like that. And then here's y equals 2, here's y equals 1. And I got everybody, right? And the x, and the y-axis. So that's what it looks like. All right, good. Chop. Come on, chop. All right, so I want to rotate that bad boy around the y-axis. So dy, so what's my limits going to be?
1 to 2.
1 to 2, I like it.
Yeah.
And what do I throw in here? Now, what's the idea? I need to... Well, pi, right? It's pi r squared, basically. There's no washers here, right? Because and again, does this make sense? My region is sitting on the axis. There's no empty part. So that's what you're worried about. There's no empty part. It's sitting on the axis. There's no empty part. If I rotate it around the x-axis, empty part. Oh shit.
We have to do plus. Well, I don't know.
So pi r squared. Now here's the mistake. What is e to the y squared?
E to y.
So it isn't e to the y squared, right?
No.
It's not this, because you can't integrate this. This is impossible. This is e to the y squared, which is also known. I didn't listen to you. Did you say it was e to the 2y? Which is integrable all day long. What's up?
2 times y is...
What do you do with the powers? When you raise the power to power, you multiply the powers. Right?
Yeah.
Otherwise, you get it impossible to do until you get to 2a. But this is still really ugly because you need an infinite sum of functional parts to answer this question. And now that should be easy to integrate that and do all that stuff, right? You don't even have to use U sub, right? You shouldn't have to. You could. It would work. But what's the integral of that? Over 2. And you should evaluate it from, and don't forget your pi little dude, 1 to 2. I like it. Okay. All right. Anything else from homework? I was told there were a lot of questions.
I want to make sure that just the whole concept of the 19 through 30 section. Yeah.
Oh, good. Yeah. 19 through 30 is weird. A little weird the way they gave it to us. All right. Let's do one of those. All right. The definition of insanity. All right. So here's the way they give you 19 through 30. They give you this weird-ass jigsaw puzzle of regions. So let's try to do number 22.
24.
I can't see 24. So what's 24 say? We'll do one of the homework problems. How many? What did I sign? Was it 21, 24?
21, 24,
27, 30. So there's 4 of those problems you got to do.
Yeah.
All right. So I'm okay with doing one homework problem. Okay. So we'll do 24. 24 says.
Or 2 numbers.
Yeah. Rotate region 2 around the OC. All right, so we see. So region 2 is
The top. The green top.
yeah. Where do they tell you?
OC is 0 to 1.
It's the y-axis.
Right. Yeah, but region 2 is this guy, and this here. Did they tell you what this is? Oh, there it is. Oh,
Yeah.
I didn't see that. Y equals the 4th root of x, and this, of course, would be
1.
y equals x. Right, so that's y equals the 4th root of x. Cool, I like it. Very weird way to give you a problem, I agree. But oh well, to it. So that green area. So let's consolidate. Let's summarize what's true about that region. Summarize what's true. So what do we know about region 2? We know it's
Just do something.
like that. So what's it bounded by?
X equals 1. And so x equals 0 and y equals 1.
Yeah, so it's bounded by x equals 0, y equals 1, and y equal 3 of x. And it tells me to rotate that region 2 about the y-axis. Because that's what they call OC. All right. The OC. Alright, so if I want to rotate it on the y-axis, I need integral
dy.
dy. Good. So you can see, hopefully you understand now why it's so important to figure that out very early in the problem. So inside I'm going to need functions of y. So how am I going to rewrite this?
Y to the fourth.
X equals y to the fourth. Cool. I like it.
From 0 to 1.
Yeah, and everything's about y. So as y goes from 0 to 1, right? Then I'm going to pick up my disks. The disks end up with what, and this is not a washer problem, right? If I rotate this region around the x-axis, that'd be a washer because there's a disk that I have to cut out. There's a disk I got to cut out of this guy. All right, I like it. But here it's flush. I still like that word. It's flush with the y-axis, so I don't have an empty spot, right? So I have pi. So what's the radius?
Y
Y to the fourth. So
y to the fourth squared is 3.
yeah. So what's? I know it's new to you guys. You got to remember that. And I know what it could have been. So I'm like, what's wrong with it? But that's relatively nice problem, to be honest. Believe it or not. All right, and that's cool, right? That's not where you had the problem? You should be able to finish that one out. Where was the problem? You want to tell me or no?
Mostly I'm very uncertain about.
But is that what you had? You just weren't sure?
Yeah, that's
Okay.
what I had.
All right.
It's just, I'm very uncertain about this. Let's see. This one I can figure out. 34.
What's this?
Or it's really fun.
Oh.
That's the one where it's plus but it's not plus.
Oh yeah, so 31 through 34 says set it up, but then use your calculator to evaluate. So don't try to do it by hand. I think one of those ways is going to come out with something hard to do by hand.
The intersects, they're not full.
All right, so let's do the first little bit of 34.
Thank you. Actually, just restarted it.
So 35th, say, y squared, x squared plus y squared is 1, y greater than 0, and about the x-axis. What's y greater than equal to 0 mean?
Y greater than
The values up to.
So it's
above.
shaded
Yeah, it's above the x-axis. I like it. So the x-axis is one wall, right? And then above it, what's this?
a circle
It's a circle.
centered at 0.
So I need y equal x squared. The radius of this is going to be 1.
Okay,
So this guy's going to look like, right? Because it's a radius of 1.
yeah.
So it's going to look like this. All right, I like it. Or, it would look like a circle maybe in real life, but
Because it's constructed.
looks like a bald guy just starting to just look at us. But that's a bald guy with real problems. Seems to be. And now I've got y equals x squared. And of course, where's that going to... Now, the interesting part is, of course, if I draw this in, negative 1 is there, there. So here's the parabola, right?
Yeah.
So the region that it captures, and it wants it to be between...
The two intersect.
Yeah, this is strange the way they said this. Let me see. Y equals x squared. X equals y squared equals 1. Yeah. Y greater than or equal to 0. So... I'm pretty sure they must mean this region, but it sounds like they mean like this region.
Yeah, I thought they meant the center too, but the intersects are not whole numbers. It's like 0.786 something.
Yeah, so if you want to try to find, this is one reason why they want you to use calculators, because the limits themselves are disgusting. if you want to try to find where these intersect, you would do what? Well, better, yeah, substitution. And you can't factor that, so you have to use quadratic formula.
Yeah.
Right? My bigger issue with this is I don't think they were clear enough. I don't think they were clear enough about which region they really mean. Well, they must mean. The only reason they would say y greater equal to 0 is if they actually mean this region here. Because if they meant this region, there would be no reason to say that, right? Because the parabola is all above. Do you understand what I'm saying?
Yeah.
They didn't need to say this if they meant this, so they must mean out there. Oh yeah. Now, one way to do this officially is to do the whole that circle, rotate it, do this region, rotate it, and then subtract the two, right?
Yeah.
That is one valid way to do this. But how do we do this otherwise? Well, okay, now stay with me. We're rotating around the x-axis, right? Which means I want integral d what? Dx. Total. So two things. I need functions of x inside. Also, I'm moving along the x-axis. So where do things change on the x-axis? Do they? Like, what's the radius here?
It's fine.
The radius is just going to be the circle, which we haven't solved yet. We need to solve it for what? For y, so that's a function of x, right? And it's the top of the circle, so it's going to be y equal positive square root of 1 minus x squared. Is that cool?
Yeah.
All right, so here the radius is just going to be from there, from the x-axis to the circle. Now you guys can see where things change. Because here the radius is going to be from the x-axis to the parabola, right?
Yeah.
And of course, we don't have to do, we actually, I don't know why I'm focusing on that. We just do this side and double it. Now you have to be real careful. Not only do the functions have to be symmetric to do this, but they also have to be symmetric in relation to the axis you're rotating around. I don't know if you can't just look at it, but they do happen to be, it's the x-axis, so it's beautiful. And the volume I get there is going to be the same as the volume I get there. So I can just do 0 to 1 and double it. That'll work. But you have to be real careful about doing that. Which is really nice. So right here is the problem. And that's what Mike is asking about. He's like, well, that's gross because I got to solve this bad boy, right? So you do it. You do quadratic formula. You get your little disgusting thingamajig. The really, real quick, do it for me. What do you do? Y equal -1 plus or minus square root of 5, right? Ooh, that's the golden ratio. That's right. That's the golden ratio generator. Anyway, I'm mumbling to myself. What else is new? So here, let me show you something really cool. Let's see, before I move away from this, what does that tell me? So that tells me the y's are here, right? I need to know what the x's are, right? So y is x squared, so x is the
square root of that.
Yeah, x is squared equals y, so x equals the square root of this, which means
It's not possible. Wait, no, yeah.
Which one do I use?
You can't use the -1 minus.
You know, it's officially plus or minus. All right, let me just bring it back for a second. Are you guys understanding? Integral dx, which means two things. I need functions of x inside, and my limits will be based on what x is doing. Correct? So I need to know what x is doing, which means I need to know what the x value is at that weird-ass point where things shift. I know what the y is at that point. Well, I don't care what y is. I need to know what the freaking x is. Y is x squared, so x is square root of y. Well, plus or minus, right? In case you guys are wondering about, well, where does that guy come from? Because it's plus or minus. But we're just focusing on this half. So I'm just going to look at the positive. And one of you guys already realized I can't do -1 minus square root of 5 because then I get a complex number. It's got to be -1 plus square root of 5 over 2. All right. Ooh, this is a yummy problem.
Let's just subtract it
All
next time.
kinds of splashes. So, how do I set up this interval? It's actually going to have to be 2 integrals, right? Do you guys see that? So it's not a washer, I just have two intervals because my radius is controlled by two different functions over that x interval. Right?
Mm-hmm.
So it's going to be from 0 to that.
Can we just label that intercept?
No, watch. I'll show you something really cool. This is in the calculator, which is awesome. Do not approximate this, especially if you're going to let the calculator do it. You're just going to tell the calculator that. Because it's your calculator, you figure that shit out. What goes inside? So it's pi.
Whatever the first function is.
What's the radius? So yeah, from here, from 0 to that, it's going to go to the parabola, right?
Which is x squared.
All right.
Pi
X squared. Squared.
Plus.
Just put it all in here. Plus. Well, I'm sorry. Yeah, it's having two different angles. Pi. Now it's going from that to 1.
So it's the x squared 1 minus squared.
Yeah. Thank you. So 1. And what goes in there now? It's going from there to the circle.
Which is
So that squared is
1 minus x squared.
Yeah. See, radicals are awesome actually for these because you square it. It's awesome then. Radicals go away. So now watch this. It's kind of cool. Let me see. Maybe I should switch it up. Do it. All right. So. Ooh, look at that. Sorry. All right.
Oh, because it's a long way.
So what do we got? We got pi x to the 4th. And the first guy, right? So let's just do him first. So watch this, it's kind of cool. You ready? So we'll just do that first piece and then you can do the same thing I'm about to do in the next piece. So you guys remember how to do the integral on your calculator?
Don't
Yeah.
they actually have like integration? Like
Yeah, they do.
doing
Totally.
math? Or in the math part?
Oh yeah, they do. They do. I just like the visual.
Okay.
Yeah. But yeah, you could, there's, just to show you, they do have, here, right there. I like it. But me, I just like the visual. So if you graph this bad boy, let's see, let's zoom 6. So if you want to play along, that's what that looks like. And then I want to integrate that from, now this is awesome, it's a calculator, so it should be able to handle this. I want to integrate that from 0 to the square root of, where am I at? Okay. -1 plus the square root of 5 divided by, no, get out of there, Jeff. Now see, I'm being very careful there, right? That's the top.
Oh, yeah, you don't want to square the...
Yeah, let me make sure I got enough parentheses in there. Yes, I do. So I need a parenthesis for everything to be in the square root. I need a parenthesis for the top, right? So I'm still inside the square root.
No, you close the square.
No, he did it wrong. Because of the 5. See?
Oh, never mind.
Yeah, why? Yeah, 1, 2, 1, 2, 3. Oh, good. I got one extra one in this direction. Thank God. So I'm still in the square root, divided by 2, right? There. It's a little tiny area. Not as impressive. And then, so you just record that number, and then you put 1 minus x squared in, and you do the same thing, or pi times 1 minus x squared. You guys do?
Yeah.
Simplest mistake to make when you're doing a problem that involves a calculator is you do this, and then you forget to multiply by pi. Silly little thing. Is that right? So don't approximate this. There's no reason to for this problem because they want you to do it in the calculator anyway. Put the whole expression in so you're not rounding at all. Okay, anything else from homework?
Please. 40. And 48, like, hey, 48 is, I don't know what to do.
Oh, yeah, okay. 48's, okay.
It just says things.
So 40 is, What was that?
It makes no thing. There's stuff there. I know it's telling you something.
When it says stuff, you should do things to the stuff. All right, I forgot. 40.
40 and 48.
Yeah, 40. All right, so this is, they like doing this kind of problem. They gave us like the infinite sum, and they said, can you work out what the function was and what the boundaries were? You remember that? What the A and B were? We had problems where you have to work backwards. Because the idea is, if you're able to do a problem backwards and forwards, that means you understand it. So, 40, they give you this. I think that's it, right?
Yeah, you just say leftwards facing parabola turns into a...
So I'm going along the y-axis from -1 to 1, right? And what is this? What did they ask you for, actually? Describe the solid. Oh, I like it.
Yeah, I just cast a sloping hill thing.
So this means that, what does this mean? What is that underlying part? What is important about that? That's the radius. That's the radius, right? So that must be the function controlling. So it looks like and in fact, what are the y-intercepts of this?
Plus 1.
Difference in squares, right? -1 and 1.
Yeah.
I like it. And what makes that 0 when y is? I mean, what is it when y is 0? There it is. 1. So when y is 0, x is 1, and it makes sense it's negative, so it's a parabola facing that way. You guys all with me? So again, we're not used to sideways parabolas, but all the same. Normally it's this. If it's negative, it's that. So this is the region they're talking about here. Right? Poor little thing. So be real careful. When you rotate this, are you going to get a sphere?
No.
Of course not. Because this is not a circle. It's not part of a circle, right? It's parabolic. If it was the square root of that, do you guys see that? If that was the square root, then that would be a circle. I mean, that would be half of a circle. A half circle, yeah. Okay. So what will you get when you rotate this thing then? Like a football.
No, like spheroid.
Or whatever. Yes, however you want to describe it. An ovaloid. I like that one. Look that up. It sounds like some mutant oval. Ovaloid. Is that alright? That's all I wanted you to do, right? Was describe the solid. It is solid. No, but you need more.
So the 48, what do we do?
48. Now 48 has got almost too much freedom. A frustum, a right circular
It's a little
cone.
bit too American for its own good.
American is too American.
Sorry, I put it in there. All right, so it's got a little r, a big SR. It's got H. So I love this problem.
Right? It just says words. Exactly. You didn't see me.
So guys, I love this problem because it shows you what happens in real life. It's sort of like what you were saying. If you have a shape given to you, you don't rotate. You actually have to work backwards. What would I rotate to get the shape I've got? So I've already got a three-dimensional shape here. Where do you think I want to put where's the rotation axis?
Y.
We'll start there. Yeah, so it looks like the rotation axis would be the y-axis, and we're going to throw that right down the middle. Or pretend it's in the middle. Right? Alright, and do they tell you... Ooh, I like it. They don't tell you shit. That's awesome. Just up to you. Where do you want to put your x-axis? Hell yeah. You have complete control over this. Where your coordinate system lies is completely arbitrary. I could put it like this. And then do the math, and believe me, I've taken classes where we do that. And you got to rotate the figure and all that kind of shit. And you get the same answer, of course, because the math is ugly, but it doesn't care at the end. It gives you the same answer. But I'm definitely, if I have the option, I'm going to put that dang x-axis right there.
Fine.
Shit, yeah. So can you pick out, basically, do you see, take the rotation out?
Yeah.
What shape do you get?
It's like a trapezoid.
What's it look like?
Yeah, half a trapezoid.
Yeah, and here's little r, right? And then this goes down, and here's big R.
It's a triangle on top.
So this is, what point is this?
R.
Yeah, R, 0, right?
Yeah.
What point is this? That's weird. Right? Well, you don't know, because you don't know what that X point is. Right? But maybe it doesn't matter. All that matters is what's the Y value here, do you know? Right? H? Do you guys see that? They gave me that, right? The height is H. So what's it look like it's going, and what am I rotating around?
The y-axis.
Y-axis. So what's Y going from to?
0 to 8.
0 to H. All right, see? Now what gets interesting is, that'll be something interesting. What's this function? Let me see if they gave you anything. Okay, that's, you don't need anything. So this is where you do need to figure out what this is here, right? And there's a few different ways to do that. I don't know if you guys are getting me. I know what that point is. How do I get the equation of this? What kind of function is this? This is a line. So I need 2 points to get the equation of the line, right? I've got 1 point. I need the other point. And I was asking that before I even thought that that's what we needed, and it turns out we do. So I know part of this is H. I just got to figure out the first part. I got to figure out what this is. Well, if I can figure out what this is, and why is it easier to figure out what this is? Because this.
Hi.
So this is H here, right?
Yeah.
And I want to know what this is here. Let's see, we call this. There's no X up here yet, so we can call it X. I like it. Let me see, is there a quicker way to do that? Let me think. Oh, yeah, of course. I'm being. What am I doing? I'm sorry. I'm making this a more complicated problem than it has to be. Well, why am I being so silly? What is this? It's R. All right, we know what that is. Good Lord. So it's way easier than I thought. They give you everything. So what's the equation of this line then? How do you get the equation of the line? What do you need? This is where you guys have got to have faith in the processes you know. Just because I give you ugly shit to put into the process itself never gets harder. So to get the equation of a line, I need the slope and a point. So how do you get the slope?
H minus 0.
H minus 0 over
little r
minus big R. So it's H over R minus R. So I get Y minus, which point do you want to use? Yeah. Y minus 0 equals H over R minus R times X minus big SR, right? Is that cool? I'm just plugging in what I know in the process that I totally understand. Yeah, yes, it's good for you. And why am I going through all this trouble? Because what's my radius going to be? I got all these R's all over the freaking place, but what's my radius for my disk going to be controlled by? It's going to be controlled by the equation of that line. And since it's integral dy, I need a function of. So you're going to love the last step. You got to solve this for x. Oh.
Where's the b though?
Huh?
Where's the b?
Where's the who?
B.
The b?
B.
Oh, I'm sorry. Did I not do that? Oh, no. This is y minus y1 equals m times x minus x1.
Oh.
Yeah. I don't know. So now I just distribute, blah, blah, blah. All right, that's as far as we're going to go. I won't let you guys try that. Once you get that, that's going to be what you plug in. So what do we have so far? Integral dy, right? From what to what? And then, and here is going to go whatever you get there squared. Yeah, but just remember that little r, big R, all that crap, H, they're all constants, right? They're all constants. Don't freak out. Or, don't freak out more than you are now. All right. No more questions.
Oh, that might be the volume. So you're just like,
Oh, I see.
yeah. We just see the instructions.
That is, well, I don't blame them too much. They like snuck it in there. So you read it and you're like,
I was like,
noted. I like that.
Good to know.
I see. If that comes up on Jeopardy, I'm ready. Okay. So, in the little bit of time I have left on a beautiful Thursday, I want you guys, the region bounded by these. Sketch that out. A really good place to start is to find the X-Intercepts. Right? You with me? Try to draw a real rough sketch. If you plug in a calculator, I really don't care either to do that, but maybe try to get a little bit of it by hand. How are you doing? You okay? Yeah. I saw that when the zombie apocalypse hits, all your brains are going to taste from every tip signs. So much knowledge. That's what we're doing. We're making you good food for the zombies.
That's what it's going to be like for this.
Yes.
That's the zombie
All math
outside of
teachers are zombie feeders.
So that's what they do with math teachers when they die.
Give them to the zombies.
Let me catch up to you guys since we have very little time. What are the X-intercepts of this?
0 and
0 and 2, because you can take out
the x squared.
x squared, yes, you can 0 and 2. And, I mean, it looks a little funky. So I know I'm going from 0 to 2, so maybe at least get 1, plug a 1 in and see what that is. What is it at 1?
1.
Yeah, 1 is at 1. And we know some calculus. We know some calculus. How can I get the, how can I get the maximum, the local max? Derivative. So what's the derivative now?
4x minus, or 4x.
4x minus
Yeah.
squared.
3x squared.
So if I factor this, 0, and I get 4/3. 4/3. So at about 1 1/3 is the maximum, and whatever. So we're just going to put that a little higher. So, and we can do concavity on kind of weird crap, but let's not. Let's just not and say we did, and it looks something like that. All right, so there's Jabba the Hutt sitting the other way. Just for some.
He changed his mind. He wanted to exercise.
Sorry. All right. So, if I'm rotating this about the y-axis, you very quickly start to realize that, well, sure, but when you start trying to do that, have you got anybody realize what's going to happen here? What I'm going to need, integral d what? All right, right there you realize no. You realize no, because this is a function of. All right, now just take a minute and solve for x. All right, good. That's the appropriate. Don't try it. My teacher said to try, and I almost died. No, just say no, Jeff. No, I'm not going to do that. So obviously, my whole point here is that's motivation that we need some other method. Discs did not help us, right? There would be washing them, but it's disc. And plus, even what's this? What would I go from 0 to what? So we have to plug that in and see what the highest y is. Sorry, so there's extra work to do. All right, how are we doing so far? So don't worry about this. This is fine. I mean, disks are not all powerful. They can only operate in certain situations, right? So here's one example where they just fail horribly. So the alternate method we use. This is kind of nifty. I like this. And remember, if the disk method wants it to be dy, the shell method wants it to be dx. That immediately tells you why together they cover almost everything, right? Because this is not going to work dy. This is not going to. So if there's going to be another method, Jeff, it better be frickin' dx, or don't waste our time. Right? I understand that. It's a good point. It would be. And here's why. This method is really, really frickin' cool. I love this method. And, you know, I would. So I'm going to rotate this sucker around like that, right?
Mm-hmm.
All right. I'm not even going to try, but if you imagine, here's my little rectangle. And if I rotate this around, let me see if I can attempt this. Oh my God. Goodness gracious. Rotate this around.
Nope.
Come on, that's not just... Right? And just imagine, just for me, that's amazing. So just imagine this is halfway, right?
Yeah.
Complete it. So what shape is that in?
Sounds.
That's a shell. There you go. That's a shell. That's like a cylinder. That's the outside of a cylinder, so we call that a shell. How we do so far? And I don't know if anybody happened to look at the rest of that very colorful handout. I think the handout makes more sense once you've done some of the problems, to be honest. There's a lot on that thing, and I don't even know if I have any left. Shoot.
They have borrowed mine.
So obviously they have a much better picture up here as I try not to kill myself. That's useful, Jeff. Alright, there's what I'm talking about, right?
Shell.
Oops, wrong way. Yeehaw! Look at that, you can see it. It's amazing. The amazing thing about integrals, and the reason that we're able to do all these things, they're like a three-dimensional object, but we're using a one-dimensional integral to do it, is because the integral just adds things up. Of course, that's the main function of integral, just to add things up, right? So if I'm able to write an expression that represents any shell, no matter where I am on the x-axis, any shell, then I can just integrate that over the whole x interval, and it's going to add all of them up. And if I add all those shells up, I end up with the volume of the whole thing. Does that make sense? Scarily enough, yes, maybe. All right. And so I give you up here the idea behind what we need. Shoot. I almost remembered everything. So here is the full shell, right? That's just halfway. And there's my... Oh, yeah, it's worse over here. Hold on. It looked better from that side. So what I need to get this... Does this make sense? Where's that 2 pi r coming from? That is the circumference. I don't want the area because I don't want to multiply and pick up the whole volume of that cylinder, right? I just want to get the outer shell of that cylinder. So if I take the circumference multiplied by the height, that would just be the surface area of the sides. Let me stop there for a second, right? Oh, some of you guys are like, please stop. Come on now, stay with me. So obviously, if I take the area of a circle and I multiply by the height, that gives me the volume of the cylinder because I'm taking that circle. I need a circle there. I'm taking a circle, and if I multiply by the height, I'm getting all those circles added together. I end up with all the volume. If I don't want the middle, if I want it truly to be hollow, I take the circumference and multiply by the height. So the volume of the cylinder is pi r squared h. The surface area of the sides of the cylinder is 2 pi r h for exactly the same damn reason. Just that here, I only take the outside.
But then it's not that full. It's going to be like a really thin shell.
Yeah, and then we multiply by dx to actually make it a little tiny volume element. So that's the volume element is 2 pi r h times the thickness, which is dx again, just like before. Just like the thickness of the washer, or the disc.
Oh, okay.
That dx is just the thickness, right? And it's infinitesimally small. So, All right. So here's the main things to worry about here. You got to figure out what the radius is. All right. So that's going to be how far away it is from the, as before, it's going to be how far away any specific, so in this problem, how far, and then you got to, no, this is also, let me complete the sentence. How far is this? I picked this too specific of a problem. Let's just say, I don't know what that is. That's x. That's x away. I love it. Isn't that crazy? It would only not be x or y if my rotation axis was off axis, right? If my rotation axis was -1, then this would be x plus 1. Amazing. It's amazing. Right? So still, the radius is how far away from the axis of rotation your shell, your rectangle is. I like it. Okay. All right. And then, so the radius for this one would be x. What's the height going to be? Good. That's the height, right? I swear to God. What's happened?
So the radius.
So here's the rotation axis, right?
Yeah.
So how far away from the rotation axis am I?
A variable.
I am x away. Because I could be there, I could be there, I could be there, I could be there. So what controls how far away I am? X. I like it. How is that different from before? Before the radius was
The function.
controlled by the function, right?
Which is why I'm confused.
Now the radius is controlled by the x variable, the y variable, if I'm doing it there, and the height is controlled by the function. But if you just do this, I don't have to do 3D anything. If you just draw the region, put a little rectangle at some arbitrary x position, and then just measure things. Just measure. You know you do the radius. That's how far away from the axis, from the rotation axis to what the rectangle you just drew. So if you're doing this way, it would be y, right? And then I need the height, and the height is going to be controlled by the function. That's how tall. That's why I drew that tall. If I do it somewhere else, I'm going to draw that tall because that's different there. And now I just throw it in. What's it going to be? It's going to be the integral dx now, right? And why exactly? Because my rectangles are going to be parallel to the axis of rotation, right? Which means to locate them, I've got to move along the axis that's perpendicular to that. I don't know if you guys... I try to explain it even... I don't know if you guys should try to read what I've written on this handout.
This is adding
But
a
I think
shell.
I did a pretty good job.
So this is adding a shell.
Yes! So as you move, dx, you're going to move a little bit further out. So you're going to add this next shell in. So at the... Oh, that's horrible. At the
So
end...
your bound is from 0 to x.
It's a crime against art. Huh?
Your integral is going to go from 0 to x.
0 to what? What does x do? It goes from 0 to 2. I'm letting x start at 0 and it goes to 2. So wherever it is currently, it's going to set up a shell. So I understand what you're worried about. Well, that's why my radius is x, because it depends on where I am. It's from 0 to 2. 2 pi radius times the height, right? You guys kind of with me here?
Yeah.
Notice something that's kind of nice on this that actually sometimes is not so nice is there's no square on the function inside, right? Which sometimes makes things worse. Sometimes when there's radicals, it makes it better, right? And then that integral is really damn easy to do.
Yeah.
Everybody should agree with me. Right? It's just, of course, setting it up as always is a little bit harsher. So on Monday after the quiz, yes?
Is it not square because we're adding surface areas of all the shells together? Is that why it's not square?
Well,
No, it's
because
R
it's-
is not square.
this would be an area, right? That would be a surface area, and then when I multiply it by dx, that becomes a volume.
Okay, alright.
So, the real stupid way to answer the question is, because I don't need to square anything to make the units work. Well, that's stupid. That shouldn't be my reasoning for anything. But it's because this times that is already the area. I know that, right? That's the area, and then I multiply by the little thickness to make the volume. So why would why was it squared before? Because it was pi r squared for the area, and then I would pass it through a height.
I see.
Yes, good. So after the quiz, we'll focus on shells, and then hopefully I'll be able to show you some examples that you can actually do either way. Or some examples where to see if you could pick out which way you should do it. Which way would be easier. So that's plenty for today.
we doing the study group today?
Oh, I wasn't even thinking about it, to be honest.
Adding up this shelf and this shelf and
What's
this
up?
shelf.
Could I have the?
Oh, you didn't get one?
Oh no, I gave you that.
Oh, I'm sorry. Thank you. You gotta watch me. I'll steal what I can.